Hey there, this is Max. This is House of Force Exercise 1. In this, we're going to be using the House of Force technique in order to overwrite the malloc hook or some other function pointer that we would like to do. The three steps for this are corrupting the top chunk, allocating close to the target, and overwrite the target with another allocation. As some hints, if we use this, there's hex 20 bytes of metadata, and it's good to read through the source code to see what's going on, both in malloc and within our program. So with that, I'll start sharing my screen so we can see the code that's going on. So at the very top, you'll notice that there is a pop shell function. This is just for actually executing the shell from the malloc hook. There is a freedom, and this just gives us some leaks. So there's a leak to system, a leak to heap. This just makes it easier for exploitation. We could turn off ASLR, but I think it's good to work with these relative things at some point before we actually have to deal with getting leaks. After that, we can start actually looking at the allocations. First, we allocate the chunk first, and that's it. And then we're going to write to the size of it. So we can write some data to the top chunk. Most of the time, you'd actually have a buffer overflow to do this, but I just thought it was a little bit easier to directly write to it for the purposes of this module. After we do that write, we then do an allocation where we control the size of that data. So you can see by this temp and how big was your moment. And then we use that to call malloc. So this is the allocate close to the target step because we can allocate things of arbitrary sizes. After that, we have the final call to malloc, which is going to be the one that's going to override it. And here we have two things we can override. We can use the address of malloc. So we can use the malloc hook, or we can use the got entry for puts like we did in the mlink module. But it's encouraged to use the malloc hook because we haven't used that before. But it also is kind of neat seeing the wraparound functionality of the got entry for puts as well. So it's up to you. But I prefer the malloc hook. So with that, we can see step by step how this works. Now we're going to look at the start.py file. And there's a lot of code comments in here, and it's structured a little bit differently. Instead of just being a block of code, we have functions for every step. So the first one, we have get leaks, which I do for you. We have the value to corrupt the top chunk with. We have the size, the calc size setup, and then the code execution step. So if we look to corrupt top chunk, this is the first write we're going to do, and we are writing data to the top chunk in this case. So the only to do here is to change this to a value that actually allows us to extend the heap further, because the current one doesn't work. The next one is calculating the size to the hook. So the math is here. We want to do malloc hook minus top chunk address minus hex 20. That's what we want to do. And I calculate all this stuff for you. So the malloc hook address is here, heap base is here. All you have to do is actually calculate that size, and so we know how far we're going into memory. And then finally, we write the address of the pop shell function over the top of that final allocation on the malloc hook. So there's only two to-dos in this one, but figuring out the math is kind of tricky for the House of Force. Although there's only two inputs, I think playing around with this and working on multiple solutions is a good idea. You could also do a stack write if you really wanted to, where you overwrite the return address from main. But I think doing the got entry for puts and the malloc hook are probably the best ways to go about doing it. And then just looking at GDB and looking at the top chunk and debugging this, we're all good. Cool. So to recap, we're going to use the House of Force to overwrite the malloc hook. And we have the ability to specify an arbitrary size that we're going to go forward. And this is the move the needle principle. So have fun. I remember the first time exploiting this, having a good time with it.